Okay, here we have a bit of a trickier question. So far you've been doing dilution calculations, you've been doing them all right, and then we come across this question. It doesn't even give us the original concentration of our solution. Instead, it tells us that we made up a solution using 89.52 grams of potassium chloride, and then we put that into 1 liter of water so that the final volume was 1 liter. So we actually have a step that we need to do before the dilution calculation, which is to find the concentration of this original solution. And to do that, we're going to have to convert from grams into moles of KCl. And then we can use the formula for molarity, or for concentration. Moles over volume gives us the concentration. So we've got 3 steps essentially that we have to do here. And if we break it down for a little plan for ourselves, the first step is that we're going to go from grams of KCl to moles of KCl. Okay, and then once I'm in moles, I can calculate the concentration because I know that that's equal to moles over the volume in liters. And that will be my C1, my original concentration. And then I can do my dilution calculation, right, which is, we use that formula, C1 V1 equals C2 V2, solving for C2. So let's start with our very first step here, which is going from grams to moles. Let's go ahead and do that. Now, when we're going back a little bit because we did conversions from grams to moles earlier on in this unit, and remember that when you're starting with grams and you need to get to moles, you're going to cross that bridge by using the molar mass or the molecular weight of potassium chloride. So you need to get out your periodic table, you need to look up potassium and look up chloride and figure out what the molar mass of that compound is. So we go ahead and do that, and potassium has a mass of 39.1 grams per mole. So we're looking at the molecular weight, okay, or the molar mass. 39.1 is the mass of potassium, and chlorine has a mass of 35.5. And in this compound, there is only 1 atom of potassium and 1 atom of chlorine in every one of these, in every compound, okay, or every particle, I should say, of this compound. So we can add those together, and our molar mass is going to be 74.6 grams per mole. Let's not forget our units because they're going to be really helpful when we convert. So there's the molar mass. So then the next step here is we need to get from grams into moles, and I'm starting with 89.52 grams. So what I want here is going to be moles of potassium chloride, and what I have is 89.52 grams. Sorry about my pen here, it's not really behaving itself. That's a 5. It's a 5.52 grams. Okay, and how am I going to convert from grams to moles? I'm going to have to use this conversion factor of molecular weight. Remember that every conversion factor can be written 2 different ways, so I could also have this with the mole on the top and the grams on the bottom, and that's exactly what I need to do because I want to convert out of grams, I want to cancel those grams, and I want to end up in units of moles. Okay, so I have my 74.6 grams on the bottom and 1 mole on the top, and those grams are going to cancel. My answer is going to come out in moles, and it's going to come out to be 1.2 moles. Okay, so now I'm starting to get somewhere. I have a solution in which I've taken 1.2 moles of KCl and I've put that in 1 liter. So the next step, step number 2, is to find the concentration of my original solution. Remember, your concentration is moles divided by volume in liters, and so we have 1.2 moles of KCl divided by 1 liter, and here it's important that we're in liters, and my answer is going to come out to be, well, 1.2. Anything divided by 1 is still the same number. But now my units are moles per liter, or capital M. Okay, and so I've got my original concentration, and now the next step is just a regular dilution calculation. Let's go ahead and do that. I'm just going to create a new page here for that. So we've got C1 V1 equals C2 V2. Let's plug in what we know. We know we have a 1.2 molar solution, okay, for C1, and we're sorry, my pen just wants to make some extra lines here. I use an M that way. Okay, times by 1 liter. Okay, and equals C2, which I don't know, I'm trying to find, but I am told that my new final volume is 1.4 liters. Okay, so I can go ahead and solve for C2 now. So C2 is going to be equal to my 1.2 C1 moles per liter multiplied by 1 liter a bracket, divided by V2, which is 1.4 liters. And my answer here is going to come out to be 0.857 moles per liter. But before I report that answer, I'm always looking at my sig figs. And if you look at the three numbers that we use to calculate this, they all have two significant figures. So I need to make sure that I have two sig figs in my answer as well. And 2 sig figs will take me to the second digit, the 100th place. So I'm going to round that 5 up to a 6. So C2 is equal to 0.86 moles per liter, and that is my final concentration after I've diluted it.